Lesson 41, Demo. Today is our review day for the final exam. The test will focus on big ideas, not obscure stuff. What are these big ideas? In bold here, you can see limits, derivatives, and integrals. What is a limit? You should know what a limit means. You should be able to compute a limit given an equation or given a graph. You should be able to find limits with L'Hopital's rule. You should be able to interpret limits if there's some word problem with limits inside of it. You should know the definition of continuity and also how a function could fail to be continuous. And you should also know what it means for a function to be differentiable and how a function could fail to be differentiable. Derivatives was obviously the bulk of what we did this semester. So you should know what a derivative is generally speaking in terms of like slope of a tangent line and what that slope has to do with the crazy limit definition, right? Limit is h went to 0 of f of x plus h minus f of x over h. I probably won't ask you to use that limit definition to compute a derivative, but you should still understand where that definition came from. So I want you to be able to do derivative approximations with a graph. I want you to be able to do derivative approximations with a table of values, or you should make a table of values to calculate a derivative. I want you to be able to interpret derivatives in context in word problems. You should be able to compute using the various rules. That right there, that 5-word sentence is a ton of stuff that we talked about this semester. So not listing all of them, but product rule, quotient rule, chain rule, derivative of e to the stuff, derivative of a to the stuff, derivative of tangent of stuff, derivative of inverse sine of stuff, derivative of ln of stuff. We had a lot of rules. You should be able to use derivatives. We talked about related rates problems. Optimization was a thread throughout our course. You should be able to use derivatives to find extrema, like local maxes and mins, global maxes and mins, first derivative test or second derivative test for the local stuff, maximizing or finding the global max or min of a continuous function on a closed interval was our standard use a table where you plugged in the endpoints and critical points. You should also know what inflection points are, like what they look like on graphs and how to calculate them given the formula for a function. Okay, that again is the bulk of what we did this semester. And then in the last few classes, we have introduced integrals. If you continue on and take calculus 2, you will do a ton of work with integrals. So you should know what a definite integral is. You should be able to interpret them if I give you contextual problems. You should be able to compute a definite integral if I give you a graph or if I give you a table of information of points. You should know how to apply the first part of the fundamental theorem of calculus, and also you should know how to calculate the average value of a function. It's just a formula, but I want you to understand what that means. There is a much more detailed list in the study guide that follows. For each item in that list, try to figure out what kinds of questions I might ask that are related to that item and make sure you know the process for answering those kinds of questions. Let's look at this item from the study guide to see what I mean. Determine whether L'Hopital's rule applies to a given limit and use L'Hopital's rule to calculate limits of quotients. So we talked about L'Hopital's rule and we made sure that the first thing we did when we found a new limit was to just plug in. And if we got 0 over 0 or plus or minus infinity over plus or minus infinity, then we could do L'Hopital's rule. But if you get anything else, you cannot directly apply L'Hopital's rule. And using L'Hopital's rule, again, all the forms I just gave you are fractions. And so we're taking derivatives as we do L'Hopital's rule, but we're not using the quotient. We're actually doing derivative of top and bottom completely separately. We're using our not standard notation. When we do L'Hopital's rule, you put equal sign with an LH right on top of it. And right after you write that, of course, you're going to write a limit again, and then you'll do your derivative, and then you'll try plugging in again. So the intent of that little explanation wasn't to like reteach you L'Hopital's rule or remind you of what L'Hopital's rule is and the problems therein, but rather to give you a sort of framework for testing yourself as you go through the study guide on the pages that follow. When you read this, if you can say what I just said about, hey, here's generally what L'Hopital's rule means and the kinds of problems that it applies to and the process for using L'Hopital's rule, then you'd be in good shape. But if you didn't know anything about, like if you read the sentence and just said, oh, I think that has to do with limits, but that was it, then that's your indication. You need to go back and review, get to a place where you can look at this and say, what kinds of problems I might ask where you'd apply L'Hopital's rule, and then what the general process is for solving those problems. Okay, officially, we have a 2-hour window for this test. The test is not written to be twice as long as the other tests. It's maybe a tiny bit longer, maybe, I don't know, I'll make up like an hour and 10 minutes, hour 15. It's not supposed to be twice as long, but I will give you an extended window, but I'm not going to write in a particular one here. So when it comes to our class meeting, I'll tell you exactly what your window is, and the date and time are in the syllabus. You can use 3 sheets of reference material plus the related rates guidelines. I have been encouraging you to keep the reference sheets from the first 3 tests. I'm hoping you did that, and you will bring those 3 things with you to the final exam. Don't forget to add some stuff about the integrals that we've covered, because that was not on the 3rd test, so you didn't have anything on your reference sheet for the new stuff. On the final exam, you can only use a scientific calculator. Hopefully we'll have some to lend to you if you don't have one of your own. And so I guess that's about it. I will say I wish you the best of luck on this final exam. Know that I'm rooting for you, even though at this moment in the middle of the summer, I actually have not met you. But I trust that you've been working hard all semester, and you're going to continue to work hard between now and the final exam. Put your best foot forward on that final exam. And I do wish you the best, not just in this class, but other classes, and then beyond GCC. On a personal note, I will say that I decided to make these demo and activity videos about a week ago, and I started making these 4 days ago. This is my 4th day in a row of making these things, and in those 4 days, I have made a video for every single demo and an activity problem from all 3 of our packets. And that has been a total of, I think it's 66 videos, not counting this one. I'm estimating in each of the last 4 days I've been here making these videos for roughly 8 or 9 hours on average each day. It's been a project. I'm really hopeful that that some of you, a bunch of you, I hope, get a lot of use out of these videos, because, like I said, it's been work. I'm happy that I decided to take this project on, because I do think that it's going to be useful to a bunch of you. But if I'm being honest, I am also happy that this project is over. Looking at the clock here, I'm probably the only one on campus. It is 8:20 on a Saturday in July. I'm looking forward to getting back to my summer vacation, which is going to start right when I end this video here. So I hope this has been helpful to you. If it has, I don't know, send me an email if you have my email address, or tell me thanks in person if we meet, or anyway, just send some positive wishes my way through the cosmic universe. I hope these videos are helpful. So anyway, again, good luck on this exam and beyond, and take care.